In this video, we're going to explore where the derivatives of inverse trig functions come from. So to do that, we're going to go through a task or a few tasks that you guys are going to do after I show you how to get started. So first thing we're going to do in step one is we're going to take this equation, sine y equals x, and we're going to draw a right triangle to represent the meaning of this. So draw a right triangle, and let's look at the equation. Sine y is equal to x. This is our angle, and this is our ratio, so I'm going to make it x over 1. I need to put in my angle, which is y, and the opposite over the hypotenuse is going to be my ratio, x over 1. And if I find the side lengths of the right triangle in terms of the given variables, I have this leg, I have the hypotenuse, and this last leg would be 1 squared minus x squared square rooted if I use the Pythagorean theorem. So we're going to use this reference triangle in the next few steps to continue figuring out where the derivatives of the inverse trig functions come from. So let's look down at step 2. Alright, in step 2 what we want to do is take our equation and find the derivative of y with respect to x. So we have to take the derivative with respect to x of both sides. Derivative of sine y, and we have to take the derivative with respect to x of x. Now, for this left-hand side, you have to use implicit differentiation because you have a y and you want to take the derivative in terms of x. So if we do that, the derivative of sine is cosine, so we get cosine of y, but we took the derivative of a y with respect to the x, so we need to use the chain rule to remember that piece, and then the derivative of x is just 1. If I solve for dy dx, I get dy dx equals 1 divided by cosine of y. Alright, let's go ahead and proceed to the next step since we've got our derivative. That's right here. Okay, step 3 says use our reference triangle from step 1 to eliminate any trig operations that appear in dy dx. So if you remember what our reference triangle looked like, it was x1 square root of 1 minus x squared, and our dy over dx was 1 over cosine of y. Alright, so now what we're supposed to do is we're supposed to eliminate any trig operations. The trig operation that appears down here is the cosine of y. If you remember in our reference triangle, the y was here. So we can use our triangle to figure out the cosine of y. The cosine of y is going to equal the adjacent over the hypotenuse, which is the square root of 1 minus x squared over 1, or that's the same as the square root of 1 minus x squared. So we can rewrite this dy dx as dy dx equals 1 over the square root of 1 minus x squared, because we're going to replace that cosine of y with square root of 1 minus x squared. In this step, we're going to interpret the meaning of the derivative we just found, which is right here. But in order to do that, we need to go back to our original equation, and the hint that I've given you is solve for y first. So let's look at our sine y equals x, and to get y by itself, we need to use an inverse trig operation, which would be the arcsin. So if I take the arcsin of the left side, I need to do the same thing to the right hand side. So I'm going to rewrite that arcsin of x. And when I do that, what I get is y equals arcsin of x. And if I take the derivative of each side, which is what I want to do, I want to find what dy dx is. I'm going to take the derivative of left side, and I'm going to take the derivative with respect to x, I'll squeeze it in there, of the right hand side. So on the left we get dy dx equals the derivative with respect to x of arcsin x, but since this equation that we used for this piece here is exactly the same as the equation we used for this piece here, this dy dx is equivalent to this dy dx because they came from the same original equation. Therefore, the derivative of arcsin x is the same as dy dx, which is equal to what we have right here. So we can say that dy dx is equal to 1 over square root of 1 minus x squared. Okay, so basically these two things are exactly the same. They're equivalent. We could rewrite this as this piece. All right, let's go ahead and look at the very last step. We talked about this already just a moment ago. So if we say that dy dx is equal to 1 over the square root of 1 minus x squared, and that's the same as the derivative with respect to x of arc sine x, we have figured out what the derivative of arc sine x is. It's this piece right here. Okay, you're going to do something very similar for the arc cosine and the arc tangent. If you need to look back at this video to replicate any of those pieces, please feel free to do so.